Hello, welcome to the video notes for lesson 14-3, clustering and outliers. This begins on page 10 in your notes packet, and we are going to get started. Okay, the learning targets are: I can identify clusters of data and outliers on a scatter plot. And I can determine the association of a set of data in a scatter plot, either linear or nonlinear. So, our first example, the scatter plot shows the spine width and the page counts of 10 books. So, which two books stand out from the rest? What makes them unique? So, when I'm looking at this group of points, there are two of them in particular that look much different than the others. This one, I'll call this one A, and this one, I'll call this one B. So A and B are quite a bit different than the others. So A looks like it is about the point 1.550. So a spine width of 1.5 centimeters, about 50 pages. B looks like it is about 2.75 or 2.5. No, 2.75 in between 2.5 and 3. And 750. So what makes these two unique is one is way below and the other is way above all the other points. The rest of the points. All the rest of the points. Circle the set of data that seems to have an association. So when I'm looking at this group right here, they seem to be in a little bit of a pattern, almost like a linear, like a cluster, if you will. So, if a book has a spine width of 1.5 centimeters, how many pages would you expect the book to have? So if I go to 1.5, now we have this one down here, but all the rest are up here. So if I thought of like a line going through here, oops. Let's use the good old-fashioned line tool for this job here. Then from 1.5 up to the line, looks like it's a little above or about 300 or 325. So I'm going to say about 325 pages. And then the next question, if a book has 600 pages, what would you expect the width of the spine to be? So if we go up here, so if this were to continue up to 600 and then go down, it looks like it's about 3.5 centimeters. So you can be off by a little bit. I would say if you were off by 0.5 centimeters, I think my original key had 3 centimeters, and about 25 to 50 pages. So if you had 300 or 350, you're close enough. These do not need to be exact because they are about. Okay, over on the next page, we're going to learn about what is really going on with this topic. So a cluster is a group of points that lie close together. So the cluster for this data is right here. So that is a cluster. A gap. A gap is an area on the graph that contains no data points. So if we look, we've got two gaps. Now, let me fix that little bracket. Right here and right here. These are both gaps. And then the last one, outlier, and this is a big word here. An outlier is a piece of data that does not seem to fit with the rest of the data. So an outlier is way below or way above the rest of the data. So there's our outliers. Okay, let's take a look at the next example. The graph represents the ages and heights of several people in a classroom. Identify the cluster and outliers in the graph. Actually, you know what? I think you can go ahead and handle this on your own. Based on the graph, could you estimate the height of a 13-year-old? You should be able to. And then answer these two questions, and then check with the answer key. I want to move on to the next page, page 12, and just talk about one more big idea, and that is a nonlinear association. So when you look, some of you might be thinking, well, this is linear, it goes through here. Not exactly. It almost looks like it hooks up. And this one kind of looks like it bends down. So these are not truly linear, but they are grouped together. There's somewhat of a pattern. So you could say that there is an association. So when I look at these two examples on page 12, so this one, for example, kind of swoops down. It looks like it's almost like a negative association. So there is an association here, but it is non-linear. This one is really close to being linear, but you'll notice towards the end here it really flattens out and goes this way, and here it kind of curves down. So this is non-linear because it isn't a straight line. The one below this is very easy to tell that it's nonlinear, although some people might say, oh wait, this is a straight line. Yeah, but then once it goes like this, it looks more like an upside down absolute value than it does linear. But this is also non-linear. Now, there is a pattern, so it is a non-linear association. That's how we describe it. Alright, so over on the next page, there's some more examples. I want you to try to answer 1 and 2 as best as you can. Question 3 is going to be tricky. And notice at the bottom it says, for the key, see practice question 6. Well, that doesn't exist, so cross that out. Again, you'll have to check your answer with the answer key. So that's it. This video is real short and sweet. Don't worry, we'll make up for it in the next one. Good luck, and we will see you in math.